understand whether our um, model is consumable from a business standpoint or not, right? So a lot of machine learning models fail because they are statistically right, but when I talk about consumption, they are not the perfect ones, right? So this is where design thinking mindset again comes into picture, right? So let's say you have a model that detects fraudulent transactions in banking process, right? So it's like it will classify 0 or 1, right? You input the data, you get 0 or 1 as the output, right? And let's say while evaluating the model, you get the accuracy of 98%, right? So this definitely sounds good, and a lot of data scientists get overwhelmed by these results and um send it for deployment. But it's important to understand that what kind of data are we dealing with, and is it the right metric to look at? So let's say, over here the majority class would be transactions which were not fraudulent, and only 2% of the transaction, that is the one data point, are the ones who were that were fraudulent, right? So the data was highly imbalanced, right? This was not the correct data set to look at. And once you train the machine learning model on this data set, let's say it predicts zero value for each and every row or each and every data set, right? So the accuracy will still be 98%, considering that our data has given zero value for all the data points, out of which only two were ones, right? So that's where the machine learning model fails. So better metrics to look at for this particular case are AUC, FM score, and ROC curve. So I won't deep dive into it because it again is statistically oriented. So the idea is that um, data science alone cannot be used without having design thinking mindset. Moving on, I'll also share like some of the projects I've worked on and some of the ones I was reading. So on the basis of that, so whenever we have a classification model built, right? So we generate a confusion matrix, right? So I'll talk about. So there was a machine learning model built by some researchers in Europe that analyzes the voice of the sound of and helps in predicting whether the person has coronavirus or not, right? So prediction one means he has, and zero means he doesn't, and actual means like whether the person really had coronavirus or not, right? So confusion matrix is an important tool which helps in understanding how machine learning models are working, right? So true positives are TP stands for true positives. This represents the uh, points where a model was correctly able to predict uh, the the coronavirus patient. False negatives are the most dangerous ones over here, since the machine learning model would say, "Hey, you're good to go. You don't have coronavirus, right? Right?" But actually, he did, and that's where the cost of having false negatives over here would cause a major damage, right? As you've seen in this world, right? And false positives are the ones where we are getting false results, but that's not quite as much challenging as is false negative, because a false negative person would just walk out and spread out the virus. False positive person, he might undergo multiple tests later on and uh, might and will be saved, right? So, and then true negatives are the ones which who didn't have coronavirus, and even the model predicted that he doesn't have it. So that's where the interplay of the performance metrics come into picture. So another case study I have is for manufacturing. So in manufacturing, let's say we have a machine learning model built which helps in generating predictions whether the raw material quality was bad or good, and on the basis of that, whether the product will fail or not, right? So when you train a model, and let's say you have a greater FP, right? So greater FP means greater false positives. So that means items were which were of good quality but were classified as bad, they'll be rejected, right? And if you have a greater number of FPs, that will lead to a material wastage, right? So that is about that's how it changes from domain to domain and the business use case we were trying to solve, right? And lastly, let's say we have fraud detection case study. So over there, FP and FN have to be reduced as much as possible. We cannot compromise on one particular data point, right? So low FP means lower number of false alarms, and lower false negatives means, so yeah, of course these fraudulent transactions cause a heavy loss to banks, right? And low FP will help because whenever a fraudulent transaction has to be investigated, it takes a lot of time and causes other errors as well. So that's why both of these have to be reduced to as much as possible.